Hi, and welcome to this video on similar shapes. We're going to look at length, area and volume, and this is a higher GCSE topic. Generally I'd say it would be on the calculator paper, but depending on the sorts of numbers it could possibly be on the non-calculator paper as well. Okay, let's have a look at the sorts of things that we're interested in then. Imagine that we've got a cube. Not a very good drawing, but you'll get the rough idea. Here's our cube. Let's say it's got sides of 2 centimeters and 5 centimeters and a height of 4 centimeters. A similar cube or similar cuboid would be one that's got the same types of dimensions but all have been increased by the given scale factor. So let's say it's all got a scale factor of 2. So it's all increased scale factor 2. It's now going to have a bottom length here of 4 centimeters. This depth here is now going to be 10 centimeters because it's 2 times as big, and it's going to have a height of 8 centimeters. Now, to start with, you might assume that because the lengths have increased by a scale factor of 2, that the area and the volume will also have increased by a scale factor of 2. However, this isn't true. Let's have a quick look. If we do a table here, let's look at lengths, area of a face, or we could look at total surface area, and volume. If the length's increased by a scale factor of 2, we can see that any of these sides have gone from 2 centimeters to 4 centimeters, or from 5 centimeters here to 10 centimeters, or from 4 to 8. Let's look at the area of the front face. So the front face that we're interested in is this front face here, and we're going to compare it to the front face here. So the length was scale factor 2. The front area is going to be 2 centimeters across the bottom and 4 centimeters up. It's going to have a surface area here of 8 centimeters. So this has got a surface area of 8 centimeters. Let's look at the other cube. This has a length along the bottom of 4 and 8 up. 4 times 8 gives me 32. 32 centimeters squared. 8 centimeters squared. Now, 8 times 2 is 16, not 32. It turns out this is 4 times bigger. Okay, well let's do the same with the volume. Let's see what happens with the volume then if we look at the first cuboid and the second cuboid. The first cuboid's volume is 2 times 5 times 4, which is 40 centimeters cubed. The volume of the larger cuboid is 4 times 10 times 8. 4 times 10 is 40, times by 8 is 320 centimeters cubed. Again, 40 times 2 is 80. We'd expect it to be 80, but it's not. It's 8 times as big. The volume is 8 times as big. If we look at these numbers, we can see that there's something going on here. The length, 2, or 2 to the power of 1, the area is 2 squared, and the volume is 2 cubed. Easiest way to remember is that our units for these, remember units for the area are in squareds and in volume are cubed, so centimetre squared or centimetre cubed. Turns out that if whatever our scale factor is, let's say our scale factor is n, our area would be n squared and our volume would be n cubed. Let's look at another example. Let's take another cuboid. This time it's got a height of 2 centimeters, or let's do 2 meters, 3 meters along the bottom and 5 meters coming this way. So 5 meters up like this. Let's work out a similar shape. So here's our similar cuboid. This one has a scale factor of 3. So scale factor 3. I'm just going to pause for a second while you think about what the lengths of all the different sides are. Okay, so the side here would be 6 meters, the side down the bottom would be 9 meters, and the last side would be 15 meters. What about the area? Well, the area of, let's take this face here, was 6 meters squared. What do you think the area of this one will be? Well, let's see, if we are multiplying it by a scale factor of 3, we're actually, to work out the area, going to be multiplying it by a scale factor of 3 squared, which is 9. So we'd expect this to be 54 meters squared, and it is. 6 times 9 is 54. Similarly, with the volume, 2 times 3 times 5, 2 times 3 times 5 gives us 630 meters cubed, and here we would see 6 times 9 times 15, 54 times 15 would give us, let's just think, 54 times 15 is going to give us 810 meters cubed. What's happened with the scale factor here? Well, 30 multiplied by 3 cubed. 3 cubed would be 810. 3 cubed is 27. So our scale factor for our volume again is cubed. Let's take a further example. Let's take a reverse look this time. Let's say we've got a cylinder. Here's a cylinder. It's got a height of 20 centimeters. Here is a similar cylinder. We don't know what the volume of this one is. We know the height here is 30 centimeters, and we also know that this holds 6 liters. It has a capacity of 6 liters. In order to work out the volume or the capacity of the first cuboid here, we'd need to know by what scale factor of enlargement this has increased by. Because this is just a length. So if we can work that out, we should be able to work out the rest. Well, this has gone from 2, or from 20, up to 30. It's had a scale factor enlargement of 30 divided by 20, or 1.5. It's increased by 1.5. Let's see if we can work out then what the difference would be coming back the other way. The scale factor here was 6, and over here we're not sure what it was, but we do know that whatever it was multiplied by 1.5 cubed. Let's do some reverse engineering on this then. So we need to work out 6, and we're going to divide it by 1.5 cubed. Let's do that quickly. 6 divided by 1.5 cubed is going to give me an answer of 1.77 recurring. 1.78 litres. So we can work backwards as well using this same idea. A final example is a very typical one that you would see on an exam question. And it looks very much like this. Here is a cone. And we know, or we're told, that the area of the base of the cone is 100 centimetres squared. There is also a section of the cone, a plane that's cut here, and we're told that this is 25 centimetres squared. We're also told that the volume of the small cone at the top is 50 centimetres cubed. We're asked for the volume of the entire large cone. Now, we're not entirely sure how to go about this to start with. It's not an obvious thing that we're going to be asked to do. So let's think about going back to our first principles again. We do know that if we can work out a length, then that's going to help us. So let's just jot down a length, we've got an area, and we've got a volume. Now we know that the area was 25. We know that that area has increased to 100. 100 divided by 25 gives me 4. So the scale factor of increase here is 4. But we're dealing with areas here. The area increased by 4. That must mean that the length increased by the square root of 4, or 2. And consequently, the volume will be 2 cubed, or 8 times bigger. Now, if we know that the volume of the smaller cone was 50, to work out the volume of the larger cone, we need to do 50 multiplied by 8, which is going to give us 400 centimetres cubed. Okay, time for you to have a go at one by yourself. I'm going to do another similar one with a cone, and here it is. Here's my cone. Let's say that the area of the bottom part is 450 centimetres squared. A smaller one here is at 50 centimetres squared, and I'm going to tell you that the volume of the small cone is given as 200 centimetres cubed. I'd like to know what the volume of the large cone is. I'll pause the video, or you should pause the video now, and have a look to see if you can calculate it. You're working out the volume of the large cone. Okay, so we were given some information. We know that this has gone from 50 to 450. So a quick calculation shows that 450 divided by 50 equals 9. That was the area. So let's do length, area, volume. The area is 9. Now we need to square root that to find the length, which is 3, and that means that the volume is 3 cubed, or 27 times bigger. So to work out the volume of the large cone, we'll do 200, which was the small one, multiplied by 27, and that will give us an answer of 5,400 centimetres cubed. Okay, I hope you found this useful, and look out for other videos that should help you revise for your exams. Thank you.